Hello, my friend, and welcome to the Sleepy Scholar. Tonight, we are going somewhere quiet and strange at the same time, back to a decade when human beings, using machines no more powerful than a modern calculator, reached out past the sky and touched the edge of everything. The 1960s were not just a decade of rockets. They were a decade of small, unexplained moments, flickers of light, odd smells, strange sounds, quiet mysteries that engineers and astronauts noticed, wrote down in a logbook, and then, because there was so much else to do, simply moved past. Tonight, we will not move past them. We will linger on them, one at a time, the way you might turn a smooth stone over in your palm. If you've had a long day, and it sounds like you have, this is exactly the place for you. You don't need cosmic mysteries or deep new ideas to fall asleep. You need something just interesting enough to hold the edges of your mind still, while the rest of you lets go. That is what tonight is for. There is nowhere else you need to be right now. Nothing to solve. Nowhere to rush toward. We will wander gently through this decade of quiet, half-noticed wonders, and you can drift in and out as much as you like. You will not miss anything important. There is no test at the end of this. Before we begin, if these gentle journeys ever help you rest, you're welcome to like or subscribe, not because you need to, but because it helps other sleepy souls find their way here too, the same way you did. Now, let's get comfortable. Let your body soften into whatever is holding you right now, the mattress, the couch, the chair. You don't have to do anything with this softening. Just notice it happening, the way you'd notice a candle slowly burning down. Let your shoulders drop just slightly, away from your ears. Let your jaw loosen. Let your hands go heavy and still. You don't need to remember anything I say tonight. You don't need to follow every sentence. If your mind wanders off somewhere else entirely, that's not a failure. That's exactly what's supposed to happen. Nothing here is a test. There is no quiz, no summary, no need to hold on tightly to any of it. Let your breathing slow down, just a little more than it already has. In, and then a long, slow out. Let each breath be a small permission to let go of one more thing you were carrying today. So let your mind drift, loose and unfocused, as we begin to wander. Some of the most powerful rockets ever built were, in a very real sense, held together by guesswork. In the early 1960s, the engineers designing the Saturn rockets and the Mercury and Gemini capsules were working with slide rules, pencils, and hand-drawn blueprints. There was no way to fully simulate what would happen once metal, fuel, and human beings left the atmosphere together. So every launch was, in part, an experiment on itself. Sensors were bolted onto nearly everything, not because engineers expected trouble, but because they genuinely didn't know what to expect. And when something strange showed up on a gauge, more often than not, there wasn't time to stop and understand it. There was only time to note it and keep going. This is important to hold on to tonight, because it means the entire decade is full of small, unresolved mysteries, quiet anomalies that were true and real, and simply never fully chased down. You've probably had days like that yourself, where something small and puzzling happened, and you simply didn't have the bandwidth to explore it. You just kept moving. In a way, the whole of 1960s spaceflight was built on that same quiet permission to notice something odd and let it go, because there was somewhere else to be. There is something else worth resting on for a moment. When Yuri Gagarin, and soon after, the American Mercury astronauts left the atmosphere for the first time, engineers on the ground were extremely worried about something that sounds almost silly today. Whether a human being could swallow in zero gravity at all. Nobody knew. It seems obvious now that of course you can swallow without gravity's help. Your throat muscles do the actual work, not gravity. But in 1960, this was a genuine unknown, discussed in serious meetings, tested with parabolic flights that gave researchers only 20 or 30 seconds of weightlessness at a time. Some doctors feared an astronaut might not be able to eat or drink in orbit at all, and might quietly starve in the middle of a mission that everyone on the ground was celebrating as a triumph. It turned out, of course, to be nothing to worry about. But for a few tense months, it was one more quiet unknown, tucked between much larger unknowns. Isn't it strange to think that before we worried about walking on the moon, we worried about swallowing in space? The very largest ambitions were built on top of the very smallest uncertainties, resting one on top of the other like stones in a quiet stream. There is another story worth settling into. When John Glenn became the first American to orbit the Earth in February of 1962, he reported something that Mission Control had no explanation for at all. As his capsule, Friendship 7, moved into sunrise over the dark curve of the Earth, Glenn described seeing thousands of small, glowing particles drifting past his window, tiny points of light, swirling gently, like fireflies caught in the dark. For a moment, on the ground, there was real confusion. Nobody had predicted this. It wasn't in any manual. The explanation, when it finally came, was almost disappointingly ordinary. The particles were tiny flecks of frost, shaken loose from the capsule's outer skin, catching the sunlight as they drifted away. But in that moment, before anyone understood it, Glenn was alone above the Earth, watching an unexplained galaxy of light drift past his window, with no one on the ground able to tell him what it was. There is something oddly comforting in that. Even the calmest, most carefully trained person can find themselves surrounded by something beautiful and completely unexplained, and simply choose to watch it rather than fear it. But that is only one small part of the story. Radiation was one of the quietest and most persistent unknowns of the entire decade, and it began even before human spaceflight in 1958, when a physicist named James Van Allen discovered something completely unexpected wrapped around the Earth. Two enormous, invisible belts of charged particles trapped by our planet's magnetic field, far above the atmosphere. No one had known these belts existed. They didn't glow, they made no sound, and they couldn't be seen with the naked eye. They were only found because a simple radiation counter, flown on one of the earliest American satellites, kept reporting zero. Not low readings. Zero. It took the scientists a while to realize the sensor wasn't broken. It was being completely overwhelmed by radiation, so intense it could no longer count individual particles at all. This discovery quietly reshaped everything that came after. Every crewed mission to the moon had to be threaded carefully through these invisible belts, spending only a brief window of time inside them, timed almost like a held breath. It's strange to think that some of the most important discoveries of the space age weren't dramatic explosions or new planets, but a sensor going quiet, and a scientist noticing that the silence itself was the real story. There is another thread here, gentler than the last. During the long Gemini missions of the mid-60s, when astronauts spent days at a time in a capsule, barely larger than the front seat of a car, doctors on the ground noticed something in the biomedical telemetry that puzzled them. Astronauts' heart rates would sometimes spike sharply during rest periods for no apparent physical reason. No exertion, no danger, just a sudden, unexplained flutter on the readout, and then a slow return to normal. At the time, there wasn't much room in the schedule to investigate it deeply. It was noted, filed, and the mission moved on. Only much later did researchers begin to connect these spikes to something quieter and more human: dreaming, or the simple psychological weight of being folded into a tiny metal capsule, thousands of miles from anything solid, with only a thin wall between you and nothing at all. Even astronauts, chosen for their calm under pressure, carried something in their chest that a machine could measure, but no one could fully explain. You've likely felt your own heart do something similar. A sudden quickening for no clear reason in the middle of an otherwise still moment. Perhaps it's not so different from what those astronauts carried quietly into orbit. There's something else worth pausing on. Space, it turns out, is completely silent. No air to carry sound. Nothing to hum or hiss or creak. And yet almost every astronaut in the 1960s reported hearing something during their missions. Faint clicks, pops, ticks, and creaks, seemingly coming from nowhere. Engineers eventually attributed most of these sounds to something almost sweetly ordinary. The spacecraft's own metal skin, expanding and contracting as it moved between blazing sunlight and freezing shadow every 90 minutes. Metal groaning quietly as it changed temperature, the way an old house settles at night. But in the moment, floating in true silence, hearing these small sounds arrive from the walls around you, several astronauts described a very human feeling, as though the spacecraft itself was breathing faintly in its sleep. Perhaps that's not so far from the truth. Perhaps machines, like people, make small sounds when they're settling into stillness. There is something else worth resting on for a moment. In May of 1969, the crew of Apollo 10, flying a full rehearsal of the moon landing without actually landing, reported something over the far side of the moon that briefly unsettled mission control. An eerie, warbling, almost musical whistling sound coming through their radio while they were completely cut off from Earth, on the side of the moon where no signal could reach them at all. For a few minutes, in a transcript that stayed classified for decades afterward, the astronauts quietly debated what they were hearing, half joking, half uncertain, in the total isolation of the lunar far side. The eventual explanation was simple: radio interference between the two spacecraft components, the command module and the lunar module, briefly overlapping in a way that created an odd musical tone. But for a short while, 3 trained test pilots, further from any other human being than anyone in history, sat with an unexplained sound humming through their headsets, and no one to ask what it was. Isn't it strange how even in the most isolated place a person could possibly be, the mind still reaches for a story to explain the unfamiliar? That instinct doesn't go away, no matter how far from home you travel. There is another quiet thread worth following. Throughout the Gemini and Apollo programs, astronauts on nighttime portions of their orbits, with their eyes closed, trying to rest, began reporting something strange. Faint, painless flashes and streaks of light appearing inside their closed eyes, like distant fireworks with no sound at all. At first, this was almost dismissed as fatigue or imagination. But it happened too often to too many astronauts to ignore completely. The eventual explanation, confirmed only much later, was almost poetic. Cosmic rays, high-energy particles from distant, long-dead stars, were passing directly through the astronauts' eyeballs and brains, occasionally striking the retina or visual cortex directly, and being interpreted by the brain as a flash of light, even with the eyes fully closed. Somewhere tonight, that exact same thing may be happening to astronauts on the International Space Station, watching ancient starlight arrive, quite literally, inside their own eyes. Sit with that for a moment. light older than the sun's current cycle, arriving directly, without ever asking permission, into a human mind. Perhaps something similarly old and quiet is settling into you right now as you listen. There is something else worth pausing on. When the Apollo 11 astronauts returned from the surface of the moon and finally removed their helmets inside the tiny lunar module, they were struck by something no training manual had ever mentioned: a smell. Lunar dust, tracked in on their suits and boots, had a distinct odor. Many astronauts across multiple missions independently described it the same way, without comparing notes beforehand. Something like spent gunpowder, or the smell left behind after a firework has gone off. No one had predicted this. The moon, after all, is airless and lifeless, and nothing should smell like anything at all. The leading explanation, still debated today, is that the sharp, jagged edges of lunar dust particles, untouched by wind or water erosion for billions of years, react chemically the moment they meet oxygen and moisture inside a spacecraft, creating that same burnt mineral scent. It's a strange thought to hold on to, that after traveling nearly 240,000 miles, past every idea of remoteness we had, what greeted astronauts at the door was something as ordinary and human as a smell, one that, in a completely different context, you may have smelled yourself on a distant summer night. There is something else worth resting on for a moment. That same lunar dust caused a far more physical problem, one that barely made it into the news at the time. It clung to everything: suits, gloves, equipment, skin, with a strange, static insistence that no one had anticipated. Vacuuming it off, brushing it away, even washing it seemed to do almost nothing. It simply climbed back onto whatever it touched. The explanation, again, came slowly. Without wind, rain, or any atmosphere to smooth its edges, lunar dust remains sharp and jagged at a microscopic level, like tiny shards of glass, and the moon's exposure to constant solar wind gives its surface a faint static charge. The dust doesn't just sit on things, it reaches for them. Some astronauts described their spacesuits smelling of it for hours after removing their helmets. Dust ground so deeply into the fabric that it never fully came out. A tiny, stubborn piece of another world, riding home in the seams of a glove. There is something quietly moving in that, the idea that even the moon, cold and silent and untouched for billions of years, still finds a way to hold on a little, once we finally reach out and touch it. But that is only one small part of the story. Before any of the moon landings, mission planners faced a problem that sounds almost comically simple, but genuinely worried them for years. No one knew for certain whether the lunar surface could support the weight of a spacecraft at all. From a distance, the moon looked solid, gray, rocky, ancient. But some scientists, looking at how untouched and undisturbed its surface had remained for eons, worried that it might be covered in a thick layer of extremely fine, powdery dust, so deep and so soft that a lunar module might simply sink into it and vanish, the way a stone disappears into loose sand. Unmanned probes were sent ahead specifically to test this, gently prodding and photographing the surface before any human being was allowed to attempt a landing. It turned out the moon's surface, compacted over billions of years by countless tiny impacts, was firm enough to hold weight easily. But for years, some of the smartest minds on Earth seriously debated whether their spacecraft might simply disappear the moment it touched down. It's worth remembering that even the most confident-looking triumphs often stood quietly on top of years of genuine uncertainty that simply never made it into the photographs everyone remembers. There is another thread worth following here. During Gemini 9, in the summer of 1966, astronaut Gene Cernan attempted what should have been a fairly routine spacewalk, and instead found himself in one of the most exhausting and dangerous moments of his career, one that barely registered in public memory at the time. Outside the spacecraft, with nothing to brace against, Cernan discovered that every small movement, turning a bolt, reaching for a handhold, required enormous, disproportionate effort. His heart rate soared. His visor fogged over so completely from his own sweat that he lost his vision almost entirely, forced to navigate his way back into the capsule almost blind, guided only by touch and memory. At the time, this was treated mostly as an engineering lesson, a note to improve suit cooling and handholds for future missions. But it revealed something deeper, that human effort in a vacuum behaves in ways no amount of training on Earth can fully prepare you for. Simple tasks become exhausting. Familiar motions become foreign. There is something gently humbling in that. Even the most carefully trained human body still has to relearn from nothing how to move in a place it was never built for. There is something else worth pausing on. Space food in the early 60s was, by nearly every account, strange and unpleasant. Pureed into tubes, compressed into bite-sized cubes, coated in gelatin, to keep crumbs from floating dangerously through the cabin. Astronauts complained privately about the taste and texture, though rarely in public. But something odder emerged from those early meals. Many astronauts reported that their sense of taste and smell seemed to change subtly in orbit. Foods tasting blander, spices tasting sharper, familiar flavors, arriving strangely muted or strangely intensified. At the time, this was treated as a minor curiosity, worth a footnote at most. It would take decades of further spaceflight and far more sensitive instruments to begin connecting these shifts to changes in fluid distribution in the body and to a slightly stuffy, sinus-like feeling that seems to accompany long periods of weightlessness, not unlike the way food tastes different when you have a mild cold. It's a small, strange reminder that even our most basic senses are quietly shaped by gravity in ways we rarely notice until gravity is taken away. There is another quiet thread here. Sleep, more than almost anything else, turned out to be one of the hardest problems of 1960s spaceflight, and one of the least glamorous. Early capsules had no real beds, no true darkness, and constant low mechanical noise. Astronauts were often strapped into their seats to sleep, unable to turn over, drift, or find a natural resting position. Mission logs from Gemini and early Apollo missions are full of quiet notes about fragmented, shallow sleep, astronauts waking every hour, unable to settle, sometimes flying entire missions on a fraction of the rest they would have had on Earth. At the time, this was treated mostly as an inconvenience to be endured, something to push through in service of the larger mission. It would take years before mission planners began treating sleep itself as a genuine engineering problem, worthy of real design attention. Softer restraints, proper eye masks, real effort put into darkness and quiet. Perhaps there's something worth noticing in that, tonight of all nights, how something as simple as truly resting, truly letting your body settle into stillness, is not a small thing at all. It's something worth designing your whole day around, the way engineers eventually learned to design entire spacecraft around it. There is something else worth resting on for a moment. In 1962, before Sputnik and Mercury were even a decade old, researchers ran a series of quiet, strange experiments here on Earth, sealing volunteers into small isolation chambers for days at a time, cut off from clocks, daylight, and any sense of passing time, to see what would happen to the human mind in extreme isolation. A preview of what long-duration spaceflight might one day feel like. What they found surprised them. Without any external cues, most people's internal sense of time drifted rather than staying accurate. Some began operating on a 25 or 26-hour cycle instead of 24, their bodies quietly inventing a slightly longer day of their own, entirely on their own, without ever being told to. This became one of the early hints of what we now understand as the body's internal clock. Quiet, persistent, and only loosely tied to the actual sun. It's worth sitting with that thought for a moment, that somewhere inside you right now, a very old, very patient rhythm is running, gently trying to guide you toward rest, whether or not the world outside is cooperating. There is another thread worth pausing on. During Apollo missions, film brought back from cameras used both in orbit and on the lunar surface occasionally came back with strange, unexplained streaks and flashes across individual frames. Thin white lines cutting diagonally across an otherwise normal photograph, appearing in places no light source could explain. For a while, this was quietly treated as a processing or equipment flaw. Eventually, researchers realized these streaks were caused by the exact same cosmic rays that were producing light flashes in astronauts' eyes. Except this time, striking the photographic film directly, leaving a tiny, permanent trace of an ancient particle's journey burned directly into a photograph of the moon. There's something quietly beautiful in that. Some of humanity's most treasured photographs from the moon carry, embedded directly in the image, the fingerprint of something even older and further away than the moon itself. A visitor from some other corner of the galaxy, leaving its mark by accident in the corner of a photograph no one was looking at. But that is only one small part of the story. Not everything mysterious in the 60s space program came from the vacuum of space. Some of it came from something far closer to home, the ocean. After splashdown, Apollo astronauts were placed into strict quarantine, isolated from the rest of the world for weeks at a time, out of a very real, very seriously discussed fear that they might have brought something back from the moon capable of harming life on Earth. Some unknown lunar microbe, entirely unprecedented, entirely untestable in advance. Looking back, this fear seems almost gently naive. The moon, we now know with confidence, is sterile, airless, and lifeless. But at the time, no one could prove that with certainty. So astronauts who had just accomplished the most celebrated achievement of the century found themselves, days later, sealed inside a small trailer, watched carefully by scientists in respirators, treated with the same caution you might extend to a genuinely unknown visitor. There's something oddly tender in that image. Human beings so careful, so humble in the face of the unknown, that even their own triumphant heroes were treated gently, cautiously, just in case the universe had sent something back with them that no one yet understood. There is something else worth pausing on. Between the Apollo 16 and Apollo 17 missions, in August of 1972, just at the edge of our decade tonight, the sun produced one of the most powerful solar flares ever recorded, hurling a wave of dangerous radiation through the exact region of space where an Apollo crew would have been walking on the lunar surface, completely unprotected, had the timing shifted by only a few weeks. At the time, this near miss was discussed quietly among scientists, but it never became a headline. No astronauts were in danger during the actual event. But looking back, this moment is often described as one of the closest calls of the entire lunar program. An invisible, silent event, arriving without warning, missing a human crew by the width of a calendar. It's worth sitting with that thought gently, not with fear, but with a kind of quiet awe. How much of survival in space, and often here on Earth too, comes down not to control, but to timing, a kind of vast, silent luck that we rarely get to see directly. There is another thread worth following here. When astronauts left seismometers behind on the lunar surface during the later Apollo missions, one experiment produced a result that genuinely startled the scientists monitoring it back on Earth. When the ascent stage of a lunar module was deliberately crashed into the moon's surface after use, the resulting vibrations didn't fade quickly, the way an impact on Earth would. Instead, the moon rang quietly, steadily, for nearly an hour afterward, like a struck bell that simply refuses to go silent. On Earth, soil and water and layers of rock quickly absorb and dampen vibrations. But the moon, dry, rigid, and undisturbed for billions of years, seems to hold onto motion far longer than anyone expected, humming faintly to itself long after the actual impact has ended. There's something worth carrying into your own rest tonight. In that image, the idea that a single, gentle impact can continue quietly resonating, long, long after the moment itself has passed, fading slowly rather than stopping all at once. There is something else worth resting on for a moment. During the early Mercury and Gemini missions, engineers were quietly worried about something that never made it into press briefings: whether prolonged weightlessness might cause astronauts' hearts to slowly, dangerously weaken, since the heart itself is simply a muscle, and muscles unused tend to soften. There was no way to know for certain in advance. So doctors on the ground monitored returning astronauts extremely closely, watching for any sign that even a few days in orbit had done lasting damage. What they found was subtler and stranger than outright danger. Hearts did seem to work slightly less hard in orbit, since blood no longer had to fight gravity to circulate. And upon return to Earth, some astronauts felt briefly lightheaded or dizzy, their bodies needing a short period to remember how to work against gravity's familiar pull again. It's a strange, almost tender thought that your own heart right now is quietly doing work you never think about, pushing gently against gravity with every single beat, without ever asking for thanks. There is another quiet thread here. In 1965, during Gemini 4, astronaut Ed White performed the first American spacewalk and reported an experience that mission planners hadn't fully anticipated: a profound, almost overwhelming reluctance to come back inside. Floating freely above the Earth, tethered only by a thin cord, White described the experience as the most comfortable, most natural he had ever felt, so much so that when Mission Control finally ordered him back inside, he was audibly disappointed and later admitted it was the saddest moment of his life, having to return to the confines of the capsule. This reaction, genuine reluctance to leave the vast, silent openness of space, became known informally among later astronauts as something worth watching for, a kind of quiet emotional pull that space itself seemed to exert on those who experienced it directly. Perhaps there's something in that worth noticing tonight, how sometimes the most spacious, most open moments can feel more like home than anything familiar and enclosed ever did. There is something else worth pausing on. Throughout the decade, ground controllers listening to raw radio transmissions from deep space missions occasionally picked up something unsettling. Long stretches of near total silence, so complete and so featureless that some technicians described it as unnerving in a way they hadn't expected. On Earth, true silence almost never exists. There's always some faint hum, some distant sound, some trace of the world going on around you. But signals from deep space carried something different. An emptiness so total that several controllers described it, quietly, in personal notes, as the loneliest sound they had ever heard. It's a strange thing to consider, that silence itself, taken to its furthest possible extreme, can feel less like peace and more like distance. And perhaps that's part of why we build voices like this one, quiet, warm, present, because true silence, taken too far, can feel less like rest and more like being very far from anyone at all. There is another thread worth following. Early spacesuit gloves, designed in the first half of the decade, were notoriously stiff and difficult to work with, pressurized like a firm balloon, resisting every small motion of the fingers. Astronauts training for spacewalks often finished sessions with bruised, aching hands, and in several cases, damaged fingernails from the repeated pressure and friction inside the glove. This was treated, at the time, as simply the cost of doing the work, something to endure rather than something to be surprised by. It would take years of design iteration, informed by exactly this kind of quiet physical toll, before gloves became flexible enough for astronauts to perform delicate tasks without exhausting their hands within minutes. There's something worth noticing in that, how even our boldest reaches toward the unknown are, in the end, built on very small, very human costs. Sore hands, bruised nails, quiet discomfort, absorbed without complaint, in service of something larger. There's something else worth resting on for a moment. When the first lunar samples were brought back to Earth in 1969, scientists studying them found something that puzzled them for years afterward. Several moon rocks carried faint traces of magnetism, as though they had once been part of a planet with a strong, active magnetic field. Despite the fact that the moon today has no such field at all, and likely never had one on the scale needed to produce it. This quiet contradiction, magnetized rocks on a world with no magnetic engine to explain them, remained a genuine, unresolved mystery for much of the following decades, occasionally revisited, never fully settled, a small, persistent puzzle tucked inside otherwise ordinary gray stones. There's something gently poetic in that, even something as still and silent as a rock can carry, quietly inside it, the memory of an energy it no longer has, a kind of soft, physical echo of a past it can no longer explain, even to the people studying it most closely. There is another quiet thread here. Throughout Gemini and Apollo, engineers noticed a persistent and strange problem with certain plastics and materials used inside the spacecraft. Subtle off-gassing, tiny amounts of chemical vapor slowly released into the sealed cabin air over the course of a mission. In the small, enclosed volume of a capsule, breathing the same recycled air for days at a time, astronauts occasionally reported faint headaches or a strange staleness to the air that no amount of filtration seemed to fully resolve. At the time, with launch schedules pressing forward relentlessly, this was treated as a manageable nuisance rather than something worth pausing the entire program to solve. It would take the tragedy of Apollo 1, a fire that spread with terrifying speed through a cabin sealed in pure oxygen, to force a much deeper, much more careful reckoning with exactly what materials were allowed inside a spacecraft at all. A quiet reminder that some small, easily dismissed problems are, in fact, patiently waiting to become much larger ones. There is another thread worth following here. In July of 1962, a satellite named Telstar carried the first live television signal across the Atlantic Ocean, and the engineers who built it were startled by something they hadn't fully planned for. How deeply, almost emotionally, ordinary people on both continents reacted to the achievement, treating a simple black and white flicker of a flag and a clock face as something close to a miracle. Telstar itself was a strange, humble little thing. A metal sphere barely the size of a beach ball, tumbling gently through orbit, catching and relaying signals for only a few minutes at a time, whenever its path lined up correctly between two continents. Engineers had to time entire broadcasts around this small, drifting object's brief windows of usefulness, adjusting schedules again and again to catch it at just the right moment overhead. There's something worth noticing in that. Even our grandest new connections often depend on something small, quiet, and imperfect, drifting along on its own schedule, offering us only a brief window at a time to reach one another. There is something else worth resting on for a moment. A few years earlier, in 1960, NASA launched a satellite called Echo. Not a satellite full of electronics at all, but a giant, silvery balloon, 100 feet across, inflated in orbit and left to drift, reflecting radio signals simply by bouncing them off its smooth, metallic surface. Echo was bright enough to be seen from the ground with the naked eye, a slow-moving, gleaming point of light crossing the night sky. And in the years before most people understood what artificial satellites even were, more than a few startled observers mistook it for something stranger. An unexplained light, moving with quiet purpose against the stars, phoned in anxiously to local newspapers and radio stations. It was, in the end, nothing more than a very large, very shiny balloon, doing exactly what it was built to do. But for a while, it drifted through the sky, wearing an air of mystery it never asked for, simply because so few people yet understood what they were looking at. There is another quiet thread worth following. Before any human being flew, animals carried much of the earliest uncertainty on their own small shoulders. In 1957, a dog named Laika became the first living creature to orbit the Earth. And in 1961, a chimpanzee named Ham flew a full Mercury test flight, performing simple tasks under instruction to prove that a mind could still function clearly in weightlessness. What surprised researchers most wasn't failure, but how well these small test subjects adapted. Ham completed his assigned tasks in orbit only slightly slower than he had on the ground. A quiet, reassuring sign that thought itself might survive the journey intact, even if no one could yet be certain a human mind would do the same. There's something gentle worth carrying from that tonight, the idea that long before any person left the Earth, a small, patient creature went first, doing ordinary, careful work, so that the unknown might feel a little less uncertain for whoever came next. There is something else worth pausing on. In 1963, a Soviet spacecraft carried Valentina Tereshkova into orbit, making her the first woman in space, and revealed, quietly, something about the design of the Vostok capsule that had never been fully tested under real conditions. Cosmonauts had no direct manual control over re-entry at all. The spacecraft was almost entirely automated, with manual controls sealed behind a code, given to the cosmonaut only in case of a dire emergency, out of a lingering uncertainty about whether a human being could be trusted to make sound decisions after days of weightlessness and isolation. It worked exactly as intended, but the very existence of that sealed, secret override code says something quiet and human about the era. A decades-long argument running underneath all the triumphant photographs about how much trust to place in a tired, disoriented mind so far from home. There's something worth noticing in that tonight, gently. Trust, especially in moments of exhaustion, often needs a quiet backup plan, not because we don't believe in ourselves, but because we understand, kindly, how different a mind can feel after a very long day. There is another quiet thread here. In 1968, as unmanned probes orbited the moon in preparation for the crewed landings to come, tracking engineers noticed something small and persistent that no one could immediately explain. Spacecraft orbits around the moon kept drifting slightly, dipping and rising in ways that didn't match any of their careful calculations. The eventual explanation revealed something no one had expected to find. The moon's gravity isn't perfectly even. Hidden beneath its ancient, cratered surface were dense, invisible concentrations of mass, later nicknamed mascons, leftover remnants of enormous, long-ago impacts, quietly tugging passing spacecraft off their expected paths. It's a strange thing to imagine something as old and still as the moon, silently uneven beneath its surface, gently nudging everything that circles it, in ways too subtle to see, and yet too persistent to ignore. There is something else worth resting on for a moment. During several Apollo moonwalks, astronauts set up a simple, humble experiment. A thin sheet of aluminum foil, unrolled and left standing upright in the lunar soil, doing nothing but quietly catching tiny, invisible particles streaming outward from the sun. After a few days, the foil was carefully rolled up and brought home, and scientists studying it found something the sun itself had never allowed anyone to measure so directly before. A quiet, physical sample of the solar wind, the constant, gentle exhale of particles the sun sends outward in every direction, usually deflected harmlessly around the Earth by our planet's magnetic field before it ever reaches the ground. There's something worth resting in tonight, in that image. A small, ordinary sheet of foil, standing quietly on an airless world, patiently catching pieces of the sun itself, the same sun that is, right now, resting somewhere below the horizon near you, keeping watch even while it's out of sight. There is another thread worth following. Not every mystery of the decade came from space at all. Some came from something as small and simple as a stretch of wire. Engineers building the intricate electronics for Gemini and Apollo capsules began noticing thin, hair-like metallic filaments, sometimes barely visible, slowly growing outward from certain soldered connections over time. occasionally long enough to bridge a gap and cause a short circuit entirely on their own. These strange growths, now understood and called tin whiskers, seemed to emerge almost spontaneously, with no obvious trigger, sometimes months after a component had been built and sealed away. At the time, they were a quiet, nagging concern for engineers, hunted down and mitigated wherever they were found, without ever being fully, completely understood. There's something almost eerie and strangely comforting in that. Even inside careful, deliberate machines, something small and unplanned can go on quietly growing in the dark, following its own slow logic, largely unnoticed until someone happens to look closely enough to find it. There is something else worth pausing on. Spacesuit visors worn during lunar surface walks were coated in an extremely thin layer of real gold, not for decoration, but because gold reflects infrared light with remarkable efficiency, and engineers needed a way to protect astronauts' eyes and faces from sunlight that, without an atmosphere to soften it, arrived far more intensely than anything experienced on Earth. Astronauts often described the contrast this created as strange and vivid. Standing in direct sunlight, their gold-coated visors down, one side of their body would grow uncomfortably warm from unfiltered solar heat, while the shadowed side, cut off entirely from that same sunlight, could feel startlingly cold, with almost no gentle gradient of temperature in between the way there always is on Earth. It's worth imagining that contrast for a moment. The sun's full warmth on one side and near total absence of it on the other, separated only by the width of a footstep. Perhaps tonight you can imagine settling entirely into the warm side of that image, leaving the cold and the sharp edges behind. There is another quiet thread here. On the lunar surface itself, astronauts described a very specific, very unusual kind of quiet. Not simply the absence of sound, which they expected, but the complete absence of anything sound might reflect off of. No atmosphere to carry an echo, no wind to rustle across the ground. Even their own footsteps, audible only through the vibration carried up into their suits, felt strangely disconnected from the silent, motionless landscape around them. Several astronauts described this as the most profound stillness they had ever experienced, not empty in a frightening way, but complete, whole, entirely undisturbed, the way a held breath feels just before you finally let it go. Perhaps you can borrow a little of that same complete stillness right now, gently letting the ordinary sounds around you fade into the background, the way footsteps once faded into silence on a distant, ancient, undisturbed shore. There is another thread worth following here. In the early 60s, satellites and ground stations began picking up a strange, descending, almost musical tone buried inside natural radio static, a sound that seemed to fall gently in pitch over the course of a second or two, like a slow, ghostly slide whistle drifting through the airwaves. These signals, eventually named whistlers, turned out to come from ordinary lightning strikes here on Earth, their electromagnetic energy leaping up along invisible magnetic field lines stretching far out into space, curving over the top of the planet, and returning to the opposite hemisphere moments later, subtly reshaped by the long, silent journey. It's a strange thing to consider. The crackle of an ordinary thunderstorm, arcing invisibly out past the edge of the atmosphere and back again, arriving somewhere else in the world as a soft, falling whistle, carried gently along a path no one can see. There is something else worth resting on for a moment. In September of 1968, a Soviet spacecraft named Zond 5 carried a small, quiet crew around the moon and safely back to Earth, not cosmonauts, but a pair of tortoises, along with some seeds and other simple biological samples, the first living creatures from Earth to travel around the moon and return home again. The tortoises, it turned out, tolerated the journey remarkably well, losing only a small amount of weight along the way, offering a quiet, patient reassurance to worried engineers on both sides of the world that a living body could make that same journey and come home safely. There's something gently funny and gently moving in that. All at once, the first travelers to circle the moon and return were not bold test pilots at all, but two slow, steady tortoises, entirely unbothered by the historic nature of their trip. There is another quiet thread worth following. Parachutes, more than almost any other single component, quietly worried mission planners throughout the decade. Early tests on Earth revealed occasional, unpredictable failures, a chute tangling, failing to open fully, or tearing under load, for reasons that weren't always easy to reproduce or explain. The solution engineers settled on wasn't to solve the mystery entirely, but to work gently around it. Every capsule was built with multiple redundant parachutes, so that even if one failed unexpectedly, others could still bring the crew home safely. There's a quiet wisdom in that, worth carrying into rest tonight. You don't always need to solve every uncertainty completely. Sometimes it's enough to simply build in enough softness and redundancy that even the unexplained can be gently absorbed without ever becoming a crisis. There is something else worth pausing on. Lunar soil, examined closely under magnification for the first time, revealed something unexpectedly delicate. Countless tiny glass beads, smaller than grains of sand, scattered throughout the gray, dusty surface, formed billions of years ago when ancient impacts melted rock instantly and flung it outward, cooling into small, glassy spheres as they fell. Under direct sunlight, these tiny beads caused the lunar surface to sparkle faintly, an effect astronauts noticed directly beneath their boots, but which never quite came through in photographs. A small, private glimmer meant only for the handful of people who ever stood there themselves. There's something quietly lovely in imagining that. An entire hidden layer of soft, sparkling glass, scattered across an ancient gray landscape, glinting gently only for the rare few who ever get close enough to see it. There is another quiet thread here. Weightlessness turned out to have a small, constant, mildly maddening side effect that rarely made it into any official history. Things simply drifted away. Pens, tools, small pieces of equipment, left unattended for even a moment, would quietly float off across the cabin, sometimes turning up wedged behind a panel days later. Astronauts and engineers adapted the only way they reasonably could: Velcro patches, elastic tethers, and small pouches appeared on every surface of later spacecraft. A quiet, constant negotiation with an environment that simply refused to let anything stay where you'd left it. There's something almost sweetly relatable in that, tucked inside all this vastness and ambition. Even astronauts orbiting the Earth had to deal with the simple, ordinary annoyance of things going quietly missing, just like a set of keys misplaced somewhere in an ordinary house. There is something else worth resting on for a moment. In 1965, the Soviet Voskhod 2 mission carried 2 cosmonauts into orbit inside a cabin, so cramped that there wasn't room for both of them to wear full pressurized spacesuits comfortably during the flight. A quiet risk accepted simply because the mission's goals, including the first ever spacewalk, couldn't be achieved any other way with the technology available at the time. That same spacewalk very nearly ended in disaster. Cosmonaut Alexei Leonov's suit ballooned so much in the vacuum of space that he could no longer fit back through the airlock, forcing him to quietly, carefully vent some of his suit's pressure himself, at real personal risk, just to squeeze back inside. It's worth remembering gently that many of this decade's quiet triumphs were built directly on top of individual moments of real, personal risk, solved not by a large team of engineers, but by one person alone, making a careful, courageous decision in a matter of seconds. There is another thread worth following here. Once the lunar seismometers had been running for a while, scientists noticed something quietly constant, humming beneath all the larger, more dramatic signals. A steady, ongoing rain of very small meteoroid impacts, striking the moon's surface far more often than anyone had expected, each one sending a small, sharp signal rippling outward through the ground. On Earth, our atmosphere quietly burns up nearly all of this same debris before it ever reaches the surface, appearing to us only as the occasional, brief streak of a shooting star. The moon, with no atmosphere to protect it, simply receives all of it directly, continuously, in a slow, steady patter that never really stops. There's something worth noticing in that gently, tonight. A quiet, constant kind of rain falling somewhere very close to us, completely unnoticed, simply because it never gets the chance to reach all the way down to where we are. There is something else worth resting on for a moment. Extreme swings in temperature, scorching heat in direct sunlight, and bitter cold in shadow, sometimes only moments apart, put real, quiet stress on the metal and materials used throughout the decade's spacecraft, occasionally producing small, hairline cracks that engineers hadn't fully anticipated in their original testing. Rather than trying to eliminate this stress entirely, engineers learned instead to build spacecraft that could gently, safely flex and expand with the swings in temperature, absorbing the strain instead of resisting it outright, bending quietly rather than breaking. There's a soft kind of wisdom worth borrowing from that tonight. Sometimes the strongest response to a long day of small pressures isn't to resist all of it at once, but simply to allow yourself to bend a little, gently, and let the day's temperature swings pass through you instead of against you. There is another quiet thread here. With no showers or running water available, astronauts on the earliest missions relied on simple, damp wipes and a change of clothes to stay clean over missions lasting days at a time. A small, quiet compromise that mission planners initially worried might affect morale far more than it actually did. Astronauts, it turned out, adapted easily, treating the small ritual of wiping down and changing into a fresh undergarment as a welcome, calming routine amid the general strangeness of orbit. A small, familiar comfort carried carefully all the way from Earth. Perhaps there's something worth noticing in that tonight, too. How even in the strangest, most unfamiliar circumstances, small, ordinary rituals can still offer a quiet, steadying sense of home. There is something else worth pausing on. In 1971, just past the edge of our decade, it was quietly discovered that a small number of postage stamps had been carried to the lunar surface and back without full official approval, intended to later be sold privately. A strange, small scandal that briefly overshadowed the mission's actual scientific achievements in the news of the time. It's an oddly human footnote to attach to some of the most disciplined carefully trained people of the era. Even among astronauts chosen for extraordinary composure, ordinary human temptations, a bit of extra income, a private keepsake, still quietly found their way on board. There's something almost comforting in that, in its own small way. Even history's most extraordinary figures remain, underneath everything, quietly and recognizably human. There is another thread worth following, softly. Before leaving the lunar surface for the final time in our decade story, astronauts left behind a small silicon disk, no larger than a coin, engraved with tiny goodwill messages from the leaders of dozens of nations around the world. A quiet, deliberate gift, left resting gently in the dust, meant to remain there undisturbed for as long as the moon itself endures. It's still there now, resting in silence, exactly where it was placed, carrying its small, quiet messages of goodwill into a future no one who wrote them will ever personally see. There's something gently moving in imagining that tonight, some small, quiet piece of intention, resting patiently far above you, in no hurry at all, simply waiting, exactly where it was left. There is another thread worth following here. Rocket engines tested on the ground before ever flying were loud enough to be felt as much as heard. Engineers miles away described the static test firings of the largest Saturn engines as a physical pressure against the chest, rattling windows in towns several miles distant, an intensity no instrument reading had fully prepared anyone for. Some of the earliest tests also produced a strange, unexpected side effect. The sheer force of the engine's sound waves, reflecting off the ground, occasionally damaged nearby structures, never designed to withstand something so purely, physically loud. There's something worth noticing in that tonight. Gently, how even something built entirely to move upward, away from the earth, can still leave a brief, powerful mark on everything close beside it, simply through the force of its own quiet exhale. There is something else worth resting on for a moment. Ordinary adhesive tape, reliable and unremarkable on Earth, behaved strangely once carried into the vacuum of space. Some adhesives softened unexpectedly in the temperature extremes, while others became strangely brittle, flaking away from surfaces they were meant to hold firmly in place. It was a small, humble problem, easily overshadowed by grander concerns, but a persistent one. Engineers spent real time testing dozens of ordinary adhesives, searching quietly for the rare few that could be trusted to hold, unchanged, in an environment utterly unlike the one they'd been designed for. There's something gently reassuring in that, worth borrowing tonight. Even the smallest, most ordinary things sometimes need real patience and testing before they can be trusted somewhere new. And that patience is never wasted. There is another quiet thread worth following. In zero gravity, liquid fuel inside a spacecraft's tanks doesn't settle calmly at the bottom the way it would on Earth. Instead, it drifts freely, sloshing gently against the tank's walls in slow, unpredictable waves, occasionally causing fuel gauges to report readings that didn't match what was actually inside at all. Engineers had to learn to read these gauges with a kind of patient skepticism, understanding that a fluid without gravity to settle it might simply need a quiet moment to still itself again before its true measurement could be trusted. Perhaps that's worth carrying gently into your own rest tonight. The idea that some readings, some feelings, need a quiet moment to settle and still themselves before they can be trusted as true, rather than reacted to right away. There is one more thread worth resting on before we slow down further. Astronauts in orbit crossed from daylight into darkness roughly every 45 minutes, with almost none of the gentle, gradual twilight we're used to on Earth. Sunset and sunrise arriving suddenly, sharply, like a light switched off and then on again, rather than something that eases you into the chain. Cameras had to be adjusted constantly to keep up, and astronauts themselves described needing a small, quiet moment each time to simply let their eyes catch up with a world that had just changed entirely, without warning, all at once. Tonight, gladly, you don't need to adjust to anything all at once. The light around you can fade slowly, gently, exactly as slowly as you need it to. Let's rest for a moment on something gentler. Our minds, in a sense, aren't so different from the mission control rooms of the 1960s, quietly gathering signals all day long, trying to make sense of 1,000 small inputs, constantly predicting what should come next based on what has come before. Some researchers describe the brain as a kind of prediction machine, always guessing at what the next moment will bring, so it can respond quickly and stay safe. At the end of a long day, that machine is often still running, quietly trying to finish its predictions, tie off its loose threads, make sense of everything that happened. That's often what keeps a mind busy at night, even when the body is ready to rest. A slow, steady voice like this one can help that prediction machine finally relax, not by giving it more to solve, but by giving it permission to stop solving anything at all, just for tonight. There is something else worth pausing on. During Apollo 12, in November of 1969, the spacecraft was struck by lightning twice in the very first minute after launch, an event so sudden and unexpected that for several tense seconds, nearly every instrument panel on board went dark or displayed nonsensical readings, leaving both the crew and mission control briefly uncertain whether the mission could continue at all. It was, in the end, a young engineer in the control room, remembering an obscure backup switch rarely used before, who suggested flipping a single, specific control that restored power and stabilized the systems, allowing the mission to proceed almost as though nothing had happened. At the time, the entire event was treated with brisk, professional calm. A problem solved, a mission continued. But looking back, it stands as one of the strangest near misses of the decade. A rocket, struck twice by the sky itself, saved by a small, easily overlooked switch that almost no one in the room had thought to check. There's something worth holding onto in that. Even the most overwhelming, disorienting moments sometimes turn, quietly, on the smallest and most unexpected of solutions. There is another thread worth following. Throughout the decade, engineers noticed something strange and mildly unsettling about the way flames behaved during ground tests conducted in low-gravity aircraft. Without gravity to pull hot air upward and feed a flame with fresh oxygen, fire in near weightlessness burned differently. Slower, rounder, more like a soft, spherical glow than the familiar flickering tongue of flame we know on Earth. This was noted mostly as a curiosity at the time, worth a brief mention in engineering reports, but not deeply investigated. It would take decades more, and far more careful experiments aboard later space stations, before scientists began to fully understand just how strange and different fire truly becomes once gravity is taken away. It's a strange thing to imagine. Something as familiar, as ancient as fire itself, quietly transforming into something almost unrecognizable. The moment you remove the one force we've always assumed it needed, there is something else worth resting on for a moment. Photographs from Gemini missions occasionally captured something engineers hadn't fully planned for. Small, bright, star-like points moving rapidly across the frame, too fast and too erratic to be actual stars, and not matching the position of any known satellite. Most of these were eventually traced to tiny flecks of debris, paint chips, ice crystals, small bits of insulation, drifting alongside the spacecraft, catching sunlight at just the right angle to appear as brilliant points of light for a fraction of a second. But in the moment, on film, they looked uncannily like fast-moving objects streaking silently past a capsule in orbit. Rather than being treated as concerning, these were mostly filed away, quietly, as a visual curiosity. The sky at that altitude filled with far more debris and drifting matter than the empty blackness in photographs might suggest. There's a kind of gentle honesty in that. Even the emptiest looking sky, once you get close enough to it, turns out to be quietly full of small, glittering things, drifting slowly past, mostly unnoticed. There is another quiet thread here. Astronauts on several missions reported a strange perceptual shift that ground doctors found difficult to categorize. A persistent, mild sense of disorientation about which way was up, even inside a capsule with clearly labeled floors and ceilings, without gravity to anchor the inner ear's sense of balance. Some astronauts described occasionally feeling as though they were floating upside down relative to their crewmates, even while looking directly at them. A strange, low-level confusion that would sometimes resolve itself the moment they focused on a fixed visual reference point, like a switch panel or a window. At the time, this was treated mostly as a minor curiosity of adaptation, worth noting but not deeply alarming. It would take years of further study to understand just how deeply our sense of up and down depends not on some fixed truth, but on a quiet, constant negotiation between our eyes, our inner ears, and gravity itself. Perhaps that's worth remembering tonight, how much of what feels solid and certain is, in fact, a quiet agreement your body is constantly renewing, moment to moment, without you ever noticing the effort. There is something else worth pausing on. During long stretches of the Apollo missions, particularly on the journey to and from the moon, astronauts described a specific, quiet feeling that surprised even them. Profound boredom, sitting alongside profound wonder, almost at the exact same time. Hours of simply floating, monitoring instruments, watching the Earth slowly shrink behind them, gave astronauts long, uninterrupted stretches with nothing urgent to do. A kind of stillness that some found unexpectedly difficult, and others found unexpectedly peaceful. Michael Collins, orbiting alone above the far side of the moon, while his crewmates walked on its surface below, later described that solitude not as frightening, but as one of the most serene experiences of his life, a profound, chosen aloneness, wrapped in silence, with the entire universe quietly keeping him company. There's something gentle worth borrowing from that tonight. Stillness, even when it feels a little strange at first, often has more peace folded inside it than we expect. If we let ourselves stay in it a little longer than usual. There is another thread worth following here. In the years just before Apollo 11, engineers debated, quite seriously, whether the lunar module's ascent engine, the single engine responsible for lifting astronauts safely off the moon's surface and back into orbit, should even have a physical ignition switch at all, since a single point of failure there could strand a crew on the moon permanently. The eventual solution was almost startlingly simple. The engine was designed with no moving parts capable of jamming or failing to ignite. Using a straightforward, elegant hypergolic reaction. Two chemicals that burst into flame the instant they touch each other, with nothing mechanical required to spark them at all. It remains one of the quiet, celebrated triumphs of the era, the most important engine of the entire mission, the one every astronaut's life depended on for the trip home, was also among the simplest and most reliable ever built, precisely because its designers chose simplicity over complexity wherever they possibly could. There's something worth carrying into rest tonight in that idea, that sometimes the most essential things in a system work best not because they're complicated, but because they've been made as simple and as sure as they possibly can be. There is something else worth resting on for a moment. Throughout the decade, whether satellites quietly transformed something that had always felt uncertain and unpredictable, daily, whether into something suddenly visible from above, tracked in real time as vast, swirling shapes of cloud, moving steadily across an otherwise calm blue curve. For the scientists watching these first images arrive, there was something unexpectedly moving about it. Storms that felt chaotic and threatening from the ground looked, from orbit, graceful and almost deliberate, vast spirals turning slowly, calmly, the way water turns in a drain, utterly indifferent to the disruption they caused far below. It's worth holding onto that image tonight, gently. Somewhere above you right now, storms are turning slowly and calmly, exactly the way they always have, entirely unconcerned with anything happening down here. There is a kind of comfort in that distance, a reminder that even the most turbulent things, seen from far enough away, become simply another quiet, steady pattern. There is another quiet thread here. Several Apollo astronauts, upon seeing the Earth in full from a great distance for the first time, small, blue, and entirely alone against an infinite black backdrop, described a sudden, overwhelming emotional shift that no training had prepared them for. A profound sense of the planet's fragility, and an equally profound sense of belonging to it completely, rather than to any single country or place on its surface. This reaction happened often enough and struck astronauts deeply enough that it eventually earned its own name among later researchers. The overview effect, a shift in perspective that seemed to arrive not from any new fact, but simply from distance itself, and from seeing something whole that had always, until then, only been experienced from the inside. There's something worth borrowing from that tonight, even without leaving the room you're in. Sometimes, simply imagining a little more distance between yourself and today's worries, between yourself and the small, tangled details of your day, can offer some of that same quiet, whole perspective even without ever leaving the ground. There is another thread worth following here. The computer that guided the lunar module safely down to the moon's surface in July of 1969 had a memory smaller than almost anything we'd recognize as a computer today. A few thousand words of storage, woven, quite literally, by hand, into tiny loops of wire and magnetic rings by workers using needles and thread, in a process closer to textile weaving than modern electronics. During the actual landing of Apollo 11, this small, humble machine suddenly began flashing an alarm no one in the simulator had ever triggered before, overloaded by more information than it expected to process at once. For a handful of tense seconds, no one on the ground was entirely certain whether it was safe to continue the descent at all. A young engineer, recognizing the specific alarm from a training exercise months earlier, quietly confirmed it was safe to proceed, and the landing continued seconds from the surface, guided by a machine with less computing power than a modern calculator. Calmly working through an overload it was never fully designed to handle so gracefully. There is something else worth resting on for a moment. Throughout the decade, spy satellites orbited quietly alongside the more famous, publicly celebrated missions, capturing photographs on actual physical film rather than anything digital, since no other method existed yet. Once exposed, that film had to come back to Earth inside a small, sealed capsule, dropped from orbit on a parachute, and caught midair by a specially modified airplane trailing a hook behind it, snagging the capsule before it ever touched the ocean below. It sounds almost like something invented for a story rather than an actual, repeated engineering procedure. And yet it worked, again and again, quietly enough that most people never learned it was happening at all, high above their heads, while the more famous missions filled the newspapers instead. There's something worth noticing in that, how much quiet, careful work often happens just out of sight, entirely unnoticed, while attention gathers around something else entirely. There is another quiet thread worth following. Early in the decade, engineers selecting astronaut candidates quietly discovered a strange, purely physical constraint that had nothing to do with skill or courage at all. The Mercury capsule was so small and so tightly built around its instruments that any candidate taller than about 5'11" simply could not fit inside it comfortably, no matter how outstanding a pilot they were. This meant that some of the era's most accomplished test pilots were quietly ruled out of consideration for reasons as ordinary and human as their height. A strange, almost gentle reminder that even the boldest ambitions of the era were, in the end, built around the very ordinary dimensions of the human body. there is something else worth pausing on. Instruments left behind on the lunar surface eventually revealed something the moon had been doing quietly, on its own, for billions of years, without anyone noticing, gently, faintly trembling. Moonquakes, far weaker than anything felt on Earth, occur on a steady, predictable rhythm, many of them tied to the same tidal pull between Earth and Moon that shapes our ocean tides here at home. Unlike Earth's quakes, caused by shifting plates, many of these deep moonquakes seem to arise from the slow, patient stretching and releasing of gravity's pull, happening far below the surface, month after month, in a rhythm almost like a slow, steady heartbeat running quietly beneath an otherwise still and silent world. Perhaps tonight you can imagine that same slow, patient rhythm, something ancient and steady, pulsing gently far beneath the surface of things, entirely unconcerned with anything happening up above. There is another thread worth resting on. Contrary to how the moon is often imagined, it isn't a perfect vacuum at all. Instruments carried there in the later Apollo missions detected an incredibly thin, almost imperceptible layer of gas clinging loosely to the lunar surface, so sparse that its individual particles rarely even collide with one another, and yet present all the same, a faint, quiet whisper of atmosphere where none was thought to exist. Scientists studying it found it puzzling and delicate to even define, thinner than anything achievable inside a laboratory vacuum chamber on Earth, yet technically still there, drifting quietly around a world otherwise considered entirely airless. There's something gently reassuring in that, in its own small way. The idea that even in the places that seem most empty and most absolute, something faint and quiet still lingers, refusing to be entirely nothing at all. There is something else worth pausing on. Astronauts walking on the lunar surface repeatedly misjudged distances in ways that puzzled them in the moment and fascinated researchers afterward. Without the soft haze of atmosphere that gently fades distant objects on Earth, mountains on the moon that appeared to be a short walk away often turned out to be miles distant. Their sharp, unfiltered outlines fooling the eye into believing they were far closer than they truly were. More than one astronaut described setting out toward what looked like a nearby ridge, only to realize, after a long, tiring walk in a heavy suit, that the ridge remained just as distant as when they started, patiently reminding them that some of the oldest tricks our eyes rely on here at home simply don't work the same way anywhere else. There is another quiet thread here. During Apollo 17, the last crewed mission to the moon in our decade's story, astronaut Eugene Cernan reported a strange, faint band of light glowing gently along the lunar horizon just before sunrise. A soft glow that shouldn't have existed at all on an airless world, with nothing to scatter light the way Earth's atmosphere does at dawn. The leading explanation, still debated by scientists long afterward, suggested that fine lunar dust, lifted ever so slightly by an electric charge from the sun, might hover just above the surface at the boundary between light and shadow, catching sunlight in a way that produced a faint, unexplained glow. The moon, in its own quiet way, offering something that almost resembled a sunrise. There's something tender in imagining that. A place with no atmosphere, no color, no wind, still managing to produce something that looked, if only for a few faint moments, a little like the soft light of dawn. There is something else worth resting on for a moment. On Christmas Eve of 1968, the crew of Apollo 8, the first human beings to ever leave Earth's orbit and circle the moon, were asked to say something to the largest television audience in history at that time, and chose, entirely of their own accord, to take turns quietly reading the opening verses of Genesis, their voices soft and steady, drifting down from lunar orbit into homes across an entire, uncertain world. It wasn't planned by any committee, and it wasn't required by any script. It was simply three tired, awestruck men, farther from home than anyone in history, choosing quiet words about beginnings, order, and light emerging gently out of darkness to describe what they were seeing outside their window. There's something worth holding on to in that tonight. How, faced with something too vast for ordinary words, three exhausted travelers reached, instinctively, for something old, simple, and quiet, rather than anything new or clever at all. There is another thread worth following. Doctors monitoring astronauts throughout the decade noticed small, temporary shifts in vision following some missions, subtle blurring, slight changes in the eye's shape, usually resolving within days of returning to Earth, and treated at the time as a minor, forgettable footnote in an otherwise long list of biomedical readings. It would take decades of much longer space flights aboard later stations before researchers began to seriously study these small vision changes as a genuine, persistent effect of extended weightlessness. A reminder that some of the quietest, most easily dismissed observations from this early decade were actually the first faint outline of something far larger, waiting patiently to be understood. There is something else worth pausing on. Photographs taken by astronauts standing on the lunar surface in full, brilliant daylight never showed a single star in the sky above them. A detail that would later fuel decades of casual confusion among people looking at the images, wondering why a place with no atmosphere at all could have a sky so completely, perfectly black and empty. The explanation was gentle and ordinary. The same brilliant sunlight reflecting off the bright lunar surface overwhelmed both the astronauts' eyes and their cameras. The way a bright street lamp can wash out the stars on an otherwise clear night on Earth. The stars were there all along, patiently unchanged, simply outshone by something closer and brighter in the same moment. Perhaps that's worth remembering gently tonight, that just because something quiet and constant isn't visible in a particular moment doesn't mean it has gone anywhere at all. It's simply waiting patiently for the brighter, louder things nearby to settle down first. There is another quiet thread worth resting on. Engineers designing the earliest capsules discovered, almost by accident, that most of their tools and switches had been laid out for right-handed use only, without much thought given to it at all. A small, ordinary oversight from Earth, carried unnoticed all the way into orbit. It was never a serious problem. It simply meant a few astronauts had to quietly adapt, reaching a little differently than felt natural, learning a small new habit in a place already full of new habits. There's something gentle in that. Even our boldest designs still carry small, human fingerprints, little unexamined habits from home, tucked quietly into even our most careful plans. There is something else worth resting on for a moment. For years, seismometers left on the moon recorded faint, unexplained thuds, arriving on no particular schedule, from no obvious source. Some were meteorites, some were moonquakes, and for a while, a few simply had no explanation at all. Scientists learned to sit with that patiently. Not every signal needs to be solved right away. Some can simply be recorded gently and left for later. Perhaps that's worth borrowing tonight for anything still unresolved in your own mind. It doesn't need solving right now. It can simply be noted gently and set aside. There is another thread worth following, softly. Every astronaut in this decade wore a small dosimeter badge, quietly measuring the invisible radiation passing through their body with every mission. A running tally no one could see or feel directly. There was a quiet, careful watchfulness in that, trusting a small, silent device to track something the body itself could never sense on its own, and trusting that watchfulness to keep them safe. Maybe there's something to rest in there too, a quiet trust that some things are being carefully looked after, even the ones you cannot feel or see yourself. There is something else worth pausing on gently as we begin to slow down. Toward the very end of the decade, as Apollo missions became almost, strangely, routine in the public eye, several astronauts privately admitted something the television broadcasts never quite captured. A quiet, persistent sadness on the journey home, at leaving behind a place so vast and so still. The moon, empty and silent and untouched, had a kind of stillness earth could never fully offer. No wind, no weather, no shifting light through leaves, just an ancient, patient calm stretching in every direction. And several astronauts described missing that stillness quietly once they returned to a world so full of motion and noise. Perhaps tonight you can borrow a little of that same lunar stillness for yourself without needing to travel anywhere at all. There is one more thing worth resting on gently before we let all of this go. By the very end of the decade, after everything, the flashes of light, the strange sounds, the near misses, the quiet, unresolved mysteries, perhaps the strangest thing of all was simply this: how much was genuinely left unexplained, filed away, moved past, in service of reaching just a little further, just a little faster than anyone thought possible. And in a way, that's all right. Not everything needs to be fully understood, to be trusted, to be gently let go of. You can let all of this soften now into a kind of loose impression rather than something to remember. There's no need to hold any of it tightly. Let your body settle a little further into stillness, wherever it happens to be resting right now. Let your breathing slow just a little more, in, and then a long, slow release. Let the weight of today loosen its grip on you, gently, the way an old spacecraft's metal skin settles quietly as it cools. Above you, right now, the sky is doing exactly what it has always done, turning slowly, steadily, the way it has for billions of years, and the way it will keep doing long after tonight, long after tomorrow, without needing anything at all from you. You don't need to hold onto that thought either. You can simply let it rest nearby, like a soft light left on in another room. Your body already knows how to rest. Sleep well, and good night.